play Leveler.
Good morning. My classroom is open. Hi. I'm going to say hi to my students real quick before we start. Right there. Can you say hello? Not yet. Look right here.
Can I?
Yeah, I'm recording right now. They're looking at you.
Hi. I have a jump rope.
Oh, you have a jump rope. That's right. Sammy, do you want to say hello?
Rope.
No. Oh, you're still sleepy. Oh my goodness, you're such a good boy. All right, Daddy's got to teach.
Macaroni.
Hey, Daddy's got to teach. Y'all get out of here. Y'all get out of here.
Macaroni. I'll pick you up. Macaroni.
Hey, y'all get out of here. I love you guys.
Oh, no.
Say me too. Mama's in the kitchen, okay? Right. No, we let Samuel out. Alright, there we go. Hey, they actually closed the door. Alrighty, good morning. Okay, so welcome to Tuesday's edition of the stream. It is April 21st, and I wanted to open up. I wanted to go ahead and open up with a question I got in email. This is a dual credit question. So this one is a little tricky in the sense that there are two ways to do the problem. The way I showed you in the notes is not what they show in the view and example. So I wanted to kind of show you what I did in the notes and what I think might be a little easier to interpret. Or let me just walk you through what the view and example is saying, because maybe it doesn't make a little sense to you. Either way, this is, by the way, 6.5, question number 19, towards the back. So 6.5 is the dot product, whenever we first learned that. Let v and w be two vectors in the plane. Their magnitudes 3 and 8 for this particular problem. Of course, your numbers are going to be different. I think they use 60 degrees every time. But find the angle between 2v plus w and v. So this is slightly different than the example we had in the notes, because in the notes we just did 2v plus w. So not only do you have to find 2v plus w, you have to also add that to v, or find the angle between those two vectors. And you can either use the law of cosines, or you can just use generic definition of dot product. And the formula v dot w is magnitude of v, magnitude of w, cosine theta. You can do that one too. I'm going to show you the law of cosines method first, and then the other way I'll just kind of click through the view and example and walk you through it, if it doesn't make sense. So for this one, so if v and w have an angle of 60 degrees between them already, just draw them in space somewhere. So v is 3 and w is 8. Whoa, wait a minute. Sorry, I got my little annotation thing. What the heck? Why aren't you drawing? It was just drawing not 2 seconds ago. What's drawing now? Okay, this is pointless. Alright. I was trying to use this little whiteboard app thing on Windows 10. I was trying to be clever and not use PowerPoint. That obviously didn't work. So let me just do what I normally do here. And we'll just flip back to the question when needed. Okay, so you've got v and w. So v is 3. In my problem, v is 3. W is 8. and the angle between them is 60 degrees. Okay, so the resultant vector 2v plus w, remember you're not going to know that until you slide v over to the end of w, and then it's 2v, so you need to make it twice as long. So if v was a magnitude of 3, you know 2v is a magnitude of 6. So you got w being 8, 2v being 6, and the resultant vector between them is from here to here. Right, so that's 2v plus w. Okay, so what we did in the example problem in the book was we used law of cosines to figure out what this was, because if right here between the original red vectors v and w, if that's 60, that means that this has to be 120. And then we know this is a magnitude of 8. We know that's a magnitude of 6. So we have everything we need for law of cosines to figure out how big 2v plus w actually is. Okay. The other tricky part about this is, okay, so I guess let's go ahead and get that magnitude real quick. We'll just use the calculator. So for this particular set of numbers for the problem, oh, whoops. Minus 2 times 8 times 6. I should be in degree mode. Let's double check real quick. Yeah, I am. Okay, so for this particular set of numbers, oh, I just realized I have to keep everything in radicals for this one. Hold on, let me type it without the square root. Oh shoot, I just gotta redo it. Because cosine of 120 would just be 1/2. I mean, I'll go ahead and type it, but negative 1/2. So square root of 148, which we know that's going to reduce, but let's just write it for now. I think it reduces. Yeah. Yeah. I mean, at least I know it divides by 4, so whatever. It will break down eventually. Alright, so square root of 148 is the magnitude of 2v plus w. So now if I rewrite the second part of the problem, so here I've got 2v plus w, which I have the magnitude of now because I got it from law of cosines earlier. And then v, which can either be here, or if you could slide it over to the other end of 2v plus w too. But now it's asking you for the angle between them. Right? Okay, so at this point you can just use a ton of geometry to figure this out. I mean, I say a ton, I shouldn't say a ton. You could represent this as another triangle. So let me use a different color here. If I scoot v over here, so the theta back here is the same thing as the theta back here, which means if I just draw this little triangle, so the resultant of that, whatever, then ignore the vector part of this for now. If you can somehow just figure out the angles of this, and you can actually get this from back here, the first picture. So if you take a look at the first picture, you see how that 60 degrees originally gets kind of chopped up a little bit whenever you draw 2v plus w in the middle of it? So we can actually use law of sines, because we're on this whole triangle kick for this problem anyways, right? You can use law of sines to figure out what this angle and this angle are. So you can solve the entire triangle essentially. Right? And the key is this triangle right here, or this angle right here. Because if you find that angle, then you can figure out how much of the 60 degrees you've chopped off. if that makes any sense. So that is the theta in this problem down here in the bottom right. Okay. So you can do law of sines to figure this out. You can go, and then we'll call this theta, I guess. So 6 over sine theta equals, and then you have, I guess we should rewrite the square root of 148, right? I know 4 divides it, but what about, oh, I'm in polar, hold on. Okay, 148 divided by x. Okay, we know 4 divides it. What else divides it? Not 9. Oh, 37 is prime. It's going to be 4 and 37. So 2 square root of 37. Okay. And then this is over sine 120 degrees. Really, this problem hasn't been that bad so far. The only really annoying part about this problem is the fact that you have to leave everything in square roots, because if you didn't notice the instructions here, which I didn't the first time, I just glanced at it. Use integers or fractions for any numbers in the expression, including any radicals. I don't know why they would ever do that to you in a vector problem, but they did. Luckily, sine of 120 is just negative square root of 3 over 2. Or sorry, positive square root of 3 over 2. So cross multiply and divide. You've got 2 square root of 37 sine theta equals 6 times negative, or 6 times positive square root of 3 over 2. So 3 square root of 3. At this point, you should have everything you need to figure out what theta is. So divide the 2 square root of 37 over inverse sine both sides. 60 minus that should be the answer. Okay? Alright, so that is number 19. I know that's a super annoying problem. If you don't like the geometry angle to this problem because it doesn't follow the view and example, and I know it doesn't, but you can actually just, let me talk you through the view and example, because that's what I've had some questions on with some students. So we're just going to pop this open real quick. Remember, your formula, your big formula here is this one, or it doesn't let me highlight, but this one right here. It's the rearranged version of, you know, a dot product definition. Oh, look. Oh, okay, so the view and example has 8 and 11. Okay. They still use 60 degrees, and then it's the same setup for the problem. So first thing they do is they substitute all the vectors. So your first vector is 2v plus w, so x gets replaced with that. Y gets replaced with v, same thing down here. Now from the second step to the third step, what they're doing is distributing the v. So this v, you know, remember dot product is like multiplication. So the v gets distributed here and here. So you've got 2v dot v. Remember the 2 is a scalar, doesn't matter. And then w dot v. The denominator doesn't change. And then down here, the definition of v dot v is the magnitude of v squared, and that we talked about that on the slide when we learned it. So this is after you have plugged in your 2 vectors for the problem. Okay, now from here, we need to figure out what to sub in for w dot v. So again, just with w and v, we're going to use the definition of dot product, and we know what the magnitude of w and v are because they gave it to us in the problem, and we know what that angle is because they gave me 60 for just those 2 angles, or those 2 vectors. Cosine of 60 is 1/2, so half of 88 is 44. That's where they're getting the 44 from. So if you go back one line of work right here, this v dot w is going to get replaced with 44. Okay. Now in the denominator, the 2v dot w, and this is what we did in the lecture notes with the law of cosines, but what you can do here is actually just write out the 2 vectors dot producted. And then here, the next few steps, you just basically have to FOIL. You have to distribute out. So do all your multiplying, FOIL, and simplify, and add everything you can. So you eventually end up with this right here. Okay. Okay, so for the v dot v, you can just do magnitude of v squared. I know the magnitude of v, it's 8, right? For the w dot w, you can just do magnitude of w squared, which I know is 11 from earlier. So the only question is the v dot w in the middle. Use the formula to replace it. And guess what? We already did that earlier. It's that same thing. It's going to be that 44. So plug in the 8 for magnitude of v, plug in the 11 for magnitude of w. So that thing, that chunk, the magnitude of 2v plus w is 553 for this particular problem. So you have every single number to plug in into the cosine formula. So remember, the magnitude is going to be square root of that. Here's the beginning line of work again after stuff has been plugged in. I now have numbers to plug in everywhere. So here is the radical for this particular problem. And then you inverse cosine both sides. Which, by the way, if you do the 60 minus inverse sine thing that we would have done, is still the right answer. By the way, you write it like this. They don't want the decimal for this problem, which is where I'm thinking it's a, not a friendly problem. If I gave you anything remotely similar to this on the test, I don't care if you give me the decimal. So, anyways, that's the actual answer. So you can see on my teacher view, if I show completed problem, see, that's how you're supposed to write the answer. Okay. All right, so that was the question that I got. Oh, I got another question about that. What's it? Statue? Not the statue problem. The back in 6-1, that word problem we did on April 9th. The only reason I know that is because I had to go back and look it up to help the student. Which one is it? No. Yeah, this one. So sailing toward the statue. So we actually did this exact one already. It was back, if you check the Google Classroom post, it is way back April 9th. Right here. Okay. So we already did this problem. If you need to figure out what the work is doing, or yeah, if you need to figure out what's going on with the work, then you can watch the video. But that has the exact problem on it, so you can look at it directly there. We did the entire thing. So. All right. I think now is as good a time as any. Oh, Taylor. How do you get 3 square root of 3? Is that back in the 6-1 problem or the 6-5 problem we were doing at the beginning? Oh, I'm sorry. Okay, I probably just missed this from a long time ago. How did I get that? I'm sorry. I did not answer your question when I was writing. The reason why we got 3 square root of 3 right here. So we set up law of sines right here. Can you see my cursor? Sorry, Taylor. So you see this law of sines. When you cross multiply and divide, sine of 120 actually gets replaced with square root of 3 over 2. And then when you do the cross multiply, the 6 times square root of 3 over 2, the 6 and the 2 reduced to 3. So that was the quote-unquote step before this one. Sorry I did not get to that, Taylor. It is hard to look at chat whenever all my writing is on a different computer. Okay, Ruth, 19 on 6-3. Sure, let's do that. Here, let me label this one. This is, what was this one again? I already forgot. It's on 6-5. Hold on, I have it over here. It was 6-5 number 19. Yeah, whatever, I'll let y'all figure that out. Okay, let's pull up 6-3 number 19. So 6.3 is law of cosines. A parallelogram has adjacent sides 7 and 13. If the shorter diagonal is 10, find the length of the longer diagonal. So, hold on, it's really going to bother me if I don't label the number on the other one. It was 6.5 number what? I've got to do this, guys. I've got to do this. Was it the last one? No. It was 19, wasn't it? Yeah, it was number 19. Okay. Alright, and now we are doing 6.3, number 19. Alright, so you've got a parallelogram. I just hear Samuel outside just yelling Pikachu over and over again. Okay. Alright. Oh, I'm going to get different numbers. So 8 and 13, shorter diagonal 11. Alright, different numbers than what I just said earlier, but 8 and 13, shorter diagonal is 11. So how long is the longer diagonal? That's x in the problem. Right? Do we get anything else in the problem statement? Sorry, my kids are being very cute outside. Okay, so the fact that it's a parallelogram does help us. So we are in law of cosines, so you would assume that we're doing law of cosines here. I think the trick here is the fact that they don't give you any numbers for the angles, right? Which is what I'm assuming bothers y'all. But you do have all three sides of a triangle, right? Because you got a side triangle in this case. If you just look, let me use a different color. Ooh, not gold, green. Okay. So if you just look at that, that's a side triangle, right? So what you can do is figure out the angles for the triangle using law of cosines. So we can pick one. I mean, we would like to have all three. I don't know if we need all three just to get the long diagonal, but just for, I don't know, educational purposes, let's go ahead and just find all three angles, because you have all the information you need to solve the entire thing. So I guess I'll write out the work. Let's say we want to find what's going to help us in the long run. It doesn't matter. Okay. Let's find that angle right there. I'll just keep it in green. Okay, so you have law of cosines, which says 13 squared equals 8 squared plus 11 squared minus 2 times 8 times 11 times cosine theta, whatever it is. And then we just do a bunch of rearranging on our calculator to get that. So we're going to inverse cosine 13 squared. We're going to subtract the 8 squared over, subtract the 11 squared over, negative 2 times 8 times 11. So that top angle is 84.8 degrees, and they do want decimals here. Yeah, one decimal place. Round all intermediate values to what? To 2. So 84.78. Right? Okay, let's do the same thing over here. Oh, I guess I should use a different color. Dark blue. There we go. That one's going to be almost the exact same setup, except the 8 squared is going to go out first. So that one, theta is going to be inverse cosine of 8 squared minus 13 squared minus 11 squared. Like that. So it's going to be really similar, except the 8s and 13s swap places. Oh, whoops. There we go. So 37.79 degrees. Alright, so the leftover gives us the third angle. And the reason why we want all three angles is because we want, if we know all of the angles, we can then do law of cosines the other way to figure out. Actually, we don't need the third one. We're just doing 180 minus. But now, brand new. Here, let's see how gold works. That's the triangle I want to solve to actually get the answer. Oh, Taylor, let me finish this problem and then I will address your question. So the gold triangle is the one you actually want to, because the longer side of the gold triangle is the longer side of the diagonal. That's what you want, right? It's a parallelogram, so this is also 13. So if I can just figure out what that angle is, then that means that I can just do traditional law of cosines to figure out the length of the side. So 84.78 plus 37.79, that gives us 100 and, let's see, what is this? 110, 120, 122.57. So that angle is 122.57. And then now you do law of cosines, you know, not having the side here. So d squared equals 8 squared plus 13 squared. I'm not confident in my mental math this morning. Hey, there we go. Okay. So minus 2 times 8 times 13 times cosine of 122.57. So that should give us the length of the longer diagonal. So square root 8 squared plus 13 squared minus 2 times 8 times 13 times cosine 122.57. 18.6. It said the final answer was 1, right? Change the numbers. Whatever. Oh look, I got 13, 8 and 13 and 11. Let's just plug it in. Hey, there we go. We did math. Okay, Taylor, your question. So the Zoom meeting, what happens to the homeworks? So what I did with the grade for the Zoom meeting is I went through every single one of your grade books. A lot of you had really, really good homework averages already. So what I did is, if you had whichever helped your average the best, I either replaced your lowest homework grade with 100, or I just took one of those assignments that we skipped and then I just placed a free extra 100 into your homework average for you. So depending on which one made your average higher, it was different for everyone. So if you see a random 100 homework grade for 5.3 or 5.5, those two that I happened to skip, that's because of the Zoom meeting. So that all got done pretty much the day after we had that meeting. Okay, Taylor, hope that answers your question. All right. So it is time for, all right, drum roll, hold on. Can y'all hear that? It's time for a Twitch drop, which I have to do manually because I am not going to sign up to be an affiliate. So let's see. Look, we actually have like 5 actual people awake. Oh, all right. Okay. Student number 5 in my chat, you win. So I'll put that grade onto my math lab pretty much as soon as the stream is over. We started this yesterday, by the way. So at a random point in the stream, I'm going to just randomly pick someone. And I keep track of it over here on my side, but you get a homework grade bumped by 5 points. All right. Okay. All right. I think I've addressed all of the questions that I've gotten, at least via email. I haven't really gotten much response as far as doing a test review stream today. I mean, I'm going to be live either way, but if y'all would like for me to answer more of your homework questions, go over the test review with you, tell you what to expect on the test tomorrow, I'll be doing that at 2 o'clock today. So, special afternoon stream just for dual credit. And I will be... I have an agenda already for going over the test review, but if you have homework questions, we can easily do that instead. And then just get you prepped for this test tomorrow. We're doing it the same as last time. So it's going to be a PDF. You can either print it out and take pictures, or PDF scan it, or just write on the PDF. I will warn you, I did say this on the stream yesterday and on the post as well. You have to submit to Google Classroom and Blackboard. And I know most of you did that last time, but there were like 3 or 4 students who they were having trouble with Blackboard. I am hoping you got that fixed by now, because you have to submit to Blackboard. If you do not submit to Blackboard, you get a 0 on the test. Again, if you do not submit to Blackboard, you get a 0 on the test. So make sure y'all hear that. By the way, my microphone's right here, so if you didn't. All right. Let's see. Other things to talk about? We've already talked about it yesterday, but extra credit checkpoint number 3 was due last night. So those of you actually doing it, hopefully y'all got that turned in. This Friday is checkpoint number 4. And really that's the last actual research portion of the paper you have to do, because, afterwards the paper and the presentation is just going to be, putting everything together and putting a nice looking PowerPoint together. And then presentations on May 5th. The last thing I have to talk about that I had on my agenda was talking about grades. You probably have heard by now that Goose Creek Memorial and Goose Creek CISD, they are not counting this semester towards class rank or GPA. They are still counting it for credit. And this also doesn't apply to your, Lee College grade. So some students have been having questions about that. So let me try to break this down as much as I can. You have 2 grades in this class, right? You've got your GCM grade and you've got your dual credit grade. Your actual Lee College grade. For me, these are always the same. For other teachers, that's not always the case. Okay? So for me, these grades will always be the same number. Now, GCM, all they care about is, do you pass or fail? Did you get above a 70 or not? Right? Lee College kind of cares about that, but they're still giving you a number grade. And to them, you have a C, B, or an A. Technically, a D would get a degree, but it wouldn't pass. So you have your numerical grade for Lee College, which still matters, and they're still doing college GPA. They're still doing that. However, if you look at that interim grading post that was on the Google Classroom back in April 9th, right here, if you look at this, okay, you have until May 29th, after I've posted grades, you have until May 29th to determine whether you want your letter grade and it actually goes to your GPA, or you can just basically not report the credit. So it's like a free drop, and you can make this decision after you see your grade. So you can take it as a pass-fail, except there's no fail. It's like a pass-skip. I don't know. I guess that's the best way to put it. And this is only for this semester and for the summer if you're taking any summer classes. Okay. So after you have looked at your actual letter grade, your number grade, you can decide, hey, do I want to take this just as a passing and it doesn't affect my GPA? Or can I just do no credit reported? And the only time you would ever do that is if you failed, right? So no credit reported, I don't even want this class on my transcript. Or you can actually take your letter grade. And this is probably, any of you that make a B or an A, you probably want to take this letter grade. But you can actually take the letter grade. I mean, if you make a C, I would probably, it depends on your major. I would probably still take the letter grade regardless. I don't know. If you're going for like a 4.0, then no, don't take the letter grade if you make a C. But again, for most of you, it's going to be a transfer credit, so it's not going to matter in the long run anyways. They only care about your GPA at the university you get your degree from, so. Okay, anything else to talk about? I don't think so. So I've explained the grading thing. I will post this video up at some point. And we are going to have a special 2 p.m. test review stream for dual credit. So I will go over the test review, and then if you have questions, you can ask that too. That's pretty much all I got. So I don't see any other questions in chat. And yeah, I explained what I did with that Zoom meeting. It was before we started all the Chapter 6 stuff, so it's not replacing any of the Chapter 6 stuff. Oh, and then the extra credit, right? Remember, it's the same as last semester. So the extra credit can impact your entire semester average by up to 5 points. And take a look at the rubric if you need to. It's pretty hard to get all 5 points, if any of you remember from the board game thing last semester. But it's possible. Just don't slack off too much on the presentation part. And then I already had, I don't know what group it is, I already had somebody say that they can't attend. Oh no, okay. I guess they pulled out. Alright. Anyways, please show up for the Zoom meeting. It'll probably, each presentation is only supposed to take 5 minutes. We have 21 groups that have survived the checkpoints up till now. Probably we'll lose 1 or 2 more before we get to the end. But it'll probably take about an hour and a half. So please block off the time accordingly. Okay, that's all I got. I'll be around for the rest of the hour. Let me know if you have any questions. I'm going to stop the recording.